PVC rod. And another one in my hand. And of course I can hit it. But if it's in equilibrium, and if I bring this rod close, nothing is happening. I can change this. If I take a piece of fur and I rub this rod and bring it close to this one, you can see attraction. Well, of course, we have to ask why, but first we can just make a conclusion. Things may attract each other after we rub them together. Now what I want to do? Okay, I want to replace these, and I'm going to rub this one with fur and see if it makes any difference. It makes. It does. Now these two rods repel each other. Now what can I do? I can try something different. I can try this combination. This is a piece of glass and silk, not fur. And now I can see they attract each other. And of course, we could repeat these experiments with many different materials, using many different types of cloth. What we would see always either attraction or repulsion, or no interaction. In the end, we would come up with a list of things which attract or repel each other. And well, if we only have two options to choose from, historically, one option was called a positive and another option was called a negative. So what did they do? By making mechanical interaction between these two objects, I've changed the state of this rod. Initially, this rod was not doing anything, but after it does something, and that means this interaction, mechanical interaction, has made a difference. The new state, the first state, the original state, the state which didn't make any difference, we call neutral. And this new state that makes a difference, we call charged. So this rod was charged. By what? By this operation. I charged it. And this rod, glass rod, was neutral, didn't make any difference, didn't affect anything, but now it is charged. It makes difference now. It attracts. So, what do we do? Well, we take one material. Historically, it was amber. And we said, if we rub that material with fur, it becomes negative. Why? Well, who knows? But if that material became negative, another material that repels it, see, same material also has to be negative. So two negatively charged materials repel each other. See? What does it mean if they attract? It means this one cannot be negative anymore. If it would have been negative, it would repel. But if it attracts, it's not negative. What's opposite to negative? Positive. So we say this glass rod now has become positively charged. So now we only have, for any object in the universe, three options. Number one, neutral or we say no charge. Number 2, negative, or we say negatively charged. And number 3, positive, or we say positively charged. That's it. And we observed that positive charge and negative charge, and this is my experiment. Question. How do we know? Well, we just have to do more digging. And now, how do we explain these experiments? We need to understand why this is my bat. Summer is not very good time for experiments on electricity, or we say electrostatics. All right. See, it is charged. Well, I can actually check. If I bring it close to this device, you can see it makes difference, it affects this. And this device has a name, an electroscope. We could call it electrometer, electrometer. And charged. This is how I can check if I have a charge in it. Also, how can I check it this way? All right, I can see deflection. We'll talk about why is it happening, but first I want to do this. Just touch it and move away. When I touched it, I made a difference. When I moved away, the difference went away. Now, instead of just touching, I'm going to do this. I'm going to kind of rub it, scratching. And now what I see, the deflection remains not equal to 0, not like this one. I can put some more charge. First, I transfer the electrons from here to this rod, and then now I'm transferring those electrons from this rod on this plate. And what is happening to electrons? Well, as we know, they hate each other. They all are the same. Opposites attracts. And because electrons are negative, they repel each other. And if they repel each other, they want to move away from each other as far as possible. So when I bring those electrons on the top of this plate is made of brass, it's metal. And this plate is connected by a metal screw to this aluminum. Well, it's an arm of an electroscope. There's a moving arm and there's fixed arm. The large, the thick one is not moving, fixed, and the small one is moving. And you can see that in time, the angle quickly decreases because of this humidity. Water molecules, they collide with this electroscope and they take away extra electrons, and the charge decreases because of that. We say this electroscope is leaking out the charge. So I would have to keep it charged again and again and again to observe the same angle of deflection. All right, so I brought electrons only on this plate, but they repel each other. And because this is all metallic, they can move easily So they start moving down, 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 and we got extra electrons on each end. And because those extra electrons also repel each other, we have forces acting on each arm. And that is why this arm starts moving away from the vertical, from the fixed arm. Again, I bring electrons on the top, they repel, run down everywhere, and here at the top we have now extra electrons, not deficiency, the opposite of that. Extra electrons here and there, and that's why we observe repulsion. This is how an electroscope works, and now what I'm doing, I'm collecting all those extra electrons back on my hand. That's what we call it discharging. Discharged, so you see no action anymore. I could use, if I have something very, very strongly charged, like this bat. Sometimes using a hand is not good enough, so I would use this aluminum foil. And now all extra electrons have been transferred from this bat onto this. See, nothing. Well, something, but that's not electric interaction, that's a mechanical interaction. How do I charge it again? And now I can transfer those electrons to this plate. Angle is not zero. All right. I will use them again soon, so I'm going to keep them. Switching back to slides. Using, well, even your finger. All right, let's see. That worked well last time. Okay, you can see that the angle is not zero, we observe deflection. Again, fer PVC. It means the fer loses electrons and the PVC becomes negative. So if I bring this bat close to this plate, it repels electrons, electrons run down, and we got extra electrons on both these ends. What I'm going to do now, touched it. Did you see it? I touched it. But I didn't touch it by this bat. I touched it by my finger. But now it is charged. What is the charge on the electroscope? That should have been the question. Well, the reason is simple, actually. I moved electrons down, and then I gave those electrons a room to run. So I removed I used my finger to remove those extra electrons from the bottom. And if the electroscope has lost electrons, that means it becomes positively charged. Now it is positive. This is what we call charged by induction. This is what we call charged by contact. Charged, but this is negative because I physically moved electrons from this bat on this electroscope, and this was positive. Lost charge already due to humidity. Well, now you know a lot